Hi there, welcome to our AS revision session where we're going to be working through various content for AS revision paper 1 on Monday. So we're going to be having a look at memory in this topic, and this is just literally going to be an overview. So it's just going to be a case where you can just watch through it and make notes and just sort of consolidate what you've been learning in your lessons, and hopefully just give you a chance just to refresh all of your memory content. But it's not in loads of detail, so you should know it for a little bit more detail for your exams. So maybe have your textbook in front of you as you're going through this. It's just kind of like a higher level recap for you. Okay, so your paper 1, as you know, this is for AS, okay, which is on Monday. A-levels the following Friday. So this is memory topic. So AS students, you can watch it, but it really is designed for a recap for the AS students. Okay, so just bear that in mind. And as you know, on Monday it's an hour and 30 minutes, 72 marks in total. Talked a bit about the grade boundaries, so it's worth looking those up. Approximately, or if you aim for 40%, you should be somewhere between a B and a C. So let's hope that they're going to be along those lines this year. And you've got 3 sections to look out for, which will include a multiple choice, a short answer, and some extended writing, which will be up to 12 marks, or it could be broken down. But there will also, remember, there'll be some research methods questions in there. So along with looking at social influence, memory, and attachment, you need to go over your research methods. So go for like types of experiment, experimental design, ethics, or types of observations, all the obvious stuff. Obviously going through as much as possible, but we're doing a little bit of a whistle-stop revision here. So for memory, the specification, and I'll be referring to this as we go through, just as a checklist. So you need to know what the multi-store model of memory is, the sensory register, short-term memory and long-term memory, and also the features for each store, so how they work, or a piece of research that supports that. Okay, so this is a table that I've pulled together just showing you the different areas or the features of each store. So you could get a question asking you to name the features of each store. So that would be just coding, capacity, duration, or it might ask you about coding in the sensory register, how information is stored, or in the short term, or in long-term memory. Okay, so it's worth remembering and learning this, taking a picture of this table, writing it out. Okay, writing it out now whilst I'm talking it through. So coding is how information is stored. So for the sensory register, it's very simple. It's the way that it enters. So the term for that is the modality specific. So sound is acoustic. Me talking, that's acoustic. That's going into your sensory register. Hopefully you're paying attention to it, and it's going into your short-term memory. So vision is iconic. So again, if you see a sparkler, the shape that makes, that's just the icon that's going into your sensory register. And then for short-term memory, it's acoustically. So just learn that. Short-term memory is encoded acoustically. That was studied by Badley, and he gave lists of words that sounded the same and sounded different. He found that recall was better when the words sounded different, and he said that that was because they were stored acoustically. So the ones that sounded the same basically all went in together and got jumbled up, and that's how they were stored. And that's why he said that short-term memory was encoded acoustically, whereas the ones that sounded different had separate stores, and therefore it wasn't encoded acoustically. He also then tested long-term memory. He gave a list of words that were semantically similar, so tall, big, large, huge, and the recall for that after 20 minutes was worse compared to, say, good, huge, hot, so semantically different words. And he said, again, because the semantically similar words got muddled up, then he said long-term memory is encoded semantically. So if you take nothing else away from this, take away the fact that short-term memory is coded acoustically, sound, long-term memory is coded semantically, meaning. Okay, so your capacity, how much information can be held. So for the sensory register, it's very high capacity, so over 100 million cells in each eye. But for short-term memory, 7 items. That was tested by Miller, who found that recall dropped off after 7 items when participants were given lists of words to recall. So again, we did this in class where you were given a list of words that were 3 words long, 4 words long, 5 words long, etc., etc. And each time you had to recall the number of words. And it was found that when the words got more than 7 items, that the recall was worse. Okay. And so Miller said that actually recall was between 5 and 9 items, and that's been repeated lots and lots of times, and it does tend to sort of fit around that. So he said 7 plus or minus 2, or 5 to 9 items, either way of remembering is fine. And long-term memory, easier. Long and unlimited. Okay, it's difficult to test, so that's what the capacity is, because how do you test how much information is in your long-term memory? It's impossible. And then duration, the length of time that information is held. So your sensory register is very difficult to test because it's a very short period of time, less than half a second. So remember that. That was tested by Sperling, who gave lists of digits that were 12 items, and he'd flash it up for a small second, and then he'd play a beep, and if it was like a various tone, if it was sort of a high, medium or low tone, the participants would know whether to recall the top, middle or bottom row. So they'd seen all of them, then they did the tone, and then they had to say the middle, top or bottom row. And he found, I'm just going to take that one from my textbook, when asked to report the whole thing, recall was much worse than when they were asked to recall one row. So they could hold a small amount of information, and then once they'd paid attention to it for the recall, then they struggled to hold all of that information. So that's possibly worth just having a little look over. So Peterson, they looked at short-term memory duration, and they said it was around 18 seconds. And he did that by testing trigrams, which are 3 digits, consonants, and the length of time would get longer and longer with an interference task, so they couldn't rehearse it. And he found that after about 18 to 30 seconds, the recall dropped off quite considerably. So just remember that, 18 to 30 seconds duration for short-term memory. And then for long-term memory, it's up to a lifetime. So Barrick gave the participants the yearbooks, various sort of variables that he tested: participants that had left school after 15 years, participants that had left school after 49 years, and he found that people could remember names from a school yearbook. Again, that's cut off slightly. So many of the participants were able to recognise the names and faces of their schoolmates almost 50 years after graduating, and that was, he compared it where they did free recall. So they had to just name all the people they went to school with, or where they had images, and that gave them a cue to help them recall, and they found that it was the recall was much better there. So again, school people that you went to school with, that's not people you think about all the time unless you're spending time with them as friends, but if you see those images, then often people can recall the names of the people they went to school with. So following on from knowing the different sort of coding capacity, duration for sensory, short-term and long-term memory, you can then also use that for your knowledge of the multi-store model. So as we go through this PowerPoint, it's just literally going to be giving you like A01 and A03 for the different topics that we need to know about. So the multi-store model of memory was developed by Atkinson and Shiffrin in 1968, describes how information flows through those 3 stores, and it's the first accurate attempt at explaining memory. It's made up of the sensory store, short-term memory, long-term memory, and this is where you could just put in capacity for short-term memory was around 7 or 5 to 9 items. Duration for long-term memory was researched to be unlimited. So you can just drop in some of those little key bits of information that you know. Sensory is where information is taken through our senses, and if paid attention to, then it goes to our short-term memory. but the store has limited capacity. So if it is rehearsed, it then goes to the long-term memory. Sorry, this is a little bit small, but hopefully you'll be able to see this okay. So the multi-store model, and this is your strengths and weaknesses. Okay, so again, for AS level, you will only get up to a 12-mark question. So the previous slide showed you like an overview. It's a little bit brief, but if you added in that extra detail from coding and capacity, duration, just some other examples, that would be absolutely fine. You can also sketch it. You can also sketch it with the sensory, short-term and long-term memory, and how paying attention, and then the rehearsal at the end. That adds you, obviously shows that detail and knowledge. So research supports the different stores, such as Baddeley showing different type of encoding and the Murdoch serial position curve. So we looked at this in class where I read out a list of words. I think there were 30 words, and it kept going more and more and more words. And then at the end, I asked you to recall all of the words, and people found that the words at the beginning, they could probably recall, and the words at the end, they had still held in their short-term memory, and that's known as the primacy and recency effect. But the ones in the middle just get kind of replaced and jumbled up. Okay, so that's a really good example because these ones have been rehearsed into long-term memory, and these ones are still held in the short-term memory. So that shows kind of the last sort of up to 7 items is when recall starts to improve, whereas here, yeah, they've been sort of held in long-term memory. And I think if you tested people the next day, they would still hold these because they're at the beginning and they've just been sealed into or consolidated into the long-term memory. So I've just explained that, but so that's good. There's obviously other research. You can use that knowledge you've learned in that table to support it. So it was supported by Miller, magic number 7. It was supported by Baddeley with different types of coding. So the acoustic coding in short-term memory and semantic coding in long-term memory. So again, you're showing 2 different types of memory there because of the differences in the encoding. So again, use the knowledge that you've learnt, the key facts, to support your theories. But a limitation is that it's too simplistic. Further research has shown that there is more going on in short-term memory than just storage, as shown in the working memory model, which is obviously the other model that you're going to be looking at. And long-term memory has more than one main store, as it has different types of stores, such as episodic, procedural, and semantic. Again, you'll have learnt that. It's too simplistic to say that we need to rehearse information for it to go into the long-term memory. It's likely that information is sometimes held because we're interested in it, or it's unique, not just through rehearsal. And we can also compare this to the working model, memory model, which shows that there is more short-term memory than just, again, those 3 basic stores. So again, you can use your knowledge that you're going to learn for the long-term memory and your knowledge for working memory to evaluate the multi-store model. Okay, again, which will get you, help you with a 12-mark essay, but also help if you're going for like 8 9s out of 16 for if you're going for A level, or just use this as just a bit of a chance to recap and practice. So this is just going on to our, from the specification, so types of long-term memory, episodic, semantic and procedural. And that was developed by Tolving, who said that there are these 3 types of long-term memory. So the first one is episodic. So that's your information that is relevant and personal to the individual. So they're time-stamped. You can remember where you were when it happened in any extra detail. It's known as being declarative. You have to kind of think about it, make a conscious effort to recall that information. You then got semantic memory, knowledge and facts, so all the stuff that you're learning for your A levels and GCSEs and AS levels is semantic knowledge. It's not time-stamped. We can't remember, or we probably could some random things, but we can't remember where we originally learned our semantic knowledge. We just add to that knowledge as we progress through our life. But it's also quite well sealed in, so it's less likely to be altered or forgotten compared to episodic memory. And then procedural memory, very similar to muscle memory. It's got our memories for actions and skills. We can recall without thinking about it. It's known as non-declarative. So examples include playing the piano, swimming, riding a bike. Now they have done questions before where they've asked to name or state a difference between episodic and semantic memory, or episodic and procedural, or any of these. So it's worth just looking through these and thinking, okay, what's the difference between episodic and procedural? So procedural is non-declarative, so you don't have to think about it, whereas episodic is declarative. Episodic is time stamped, so you could say, oh yeah, that was my breakfast this morning, and it was Rice Krispies with a banana on the side, so you can remember when you had it or maybe where you had it. Whereas procedural memory is, I can't remember where I learned to ride a bike, or when I first learnt to swim. It's not time stamped, okay? And the same with semantic memory. So as long as you can just sort of think, you know these, then you might have to pull out a difference in an exam situation. So your A03 for long-term memory, and again, these are key studies or case studies that we've looked at, which you can use to support or evaluate the multi-store model, the working memory model, and also for evidence for this for long-term memory. So HM and Clive Waring. So just as a recap, HM had his hippocampus removed when he was suffering from epilepsy. So he then had, the epilepsy was cured, but then he had other problems because he developed issues with his memory, basically. So he couldn't form any new memories. He couldn't recall, he could remember things further back in the past, but he couldn't remember things that became very close to the time when his hippocampus was removed, and as they couldn't form new memories. It seemed with further research that actually it was sort of not all of his memory was damaged, but very much so his episodic memory. So if they asked him, what did you have for lunch, or have you met this person before, and who he had met before, one of the nurses, he couldn't remember them. And there was a task that he was asked to do, to draw around the shape of a letter of a star, but it was in a mirror, so it was quite a challenging task. And they'd say, have you done this before? And he had, but he would say, no, I've never done this before. But then when he did it, each time he did it, he improved. So it showed that there were different types of long-term memory, because other parts of his long-term memory were very damaged. So it's a really good sort of case study. He was studied for 50 years as well, so they had a lot of evidence there. But obviously he's unique, he's one person, and he had epilepsy beforehand, so that could have impacted on his brain. Same with Clive Waring. Clive Waring had his hippocampus damaged, but he had sort of a virus which attacked part of his hippocampus. And so that meant that he was very severely damaged. He was known as the man with the 7-second memory. But he was still able to play the piano, not as well as he could previously, because he was very, very good. But he could still play that procedural memory was still there, but his episodic memory was very damaged. But these are clinical studies, and therefore unique individuals. Their memories may be different to other people, and therefore not generalized. There's also conflicting research for which comes from neuroimaging. So Buckner and Peterson in 1996 found that semantic memory is on the left prefrontal cortex here, and probably flipped around on the screen, but on your left, and episodic on the right. Other research links the left prefrontal cortex with episodic memories. So episodic on the left, and the right prefrontal cortex with semantic memory. So basically some research is showing that the left is for semantic, and then other research is saying the left is for episodic, and the same with the right. So it's not consistent, the research. This makes it difficult to say where there are different types of memories. There's poor agreement as to where they are located, which can affect psychology as a science, something for the A-level students to consider. Also, furthermore, with long-term memory, by understanding more about long-term memory, researchers can do much more to help people with memory problems. It appears that memory loss gets worse in the episodic memory, and Belleville devised an intervention to improve episodic memories in older people. Those that did the training performed better on a task of episodic memory than a control group, and therefore this can help be used to help people who are suffering with cognitive decline as they get older. Okay, so the next bit that we're going to be looking at is the working memory model, which is the central executive, phonological loop, visual spatial sketchpad, and episodic buffer, and the features of the model, coding and capacity. So the working memory model, your key facts are here. So it's a detailed explanation for short-term memory. So remember, short-term memory, or the multi-store model with the 3 parts of memory, sensory, short-term and long-term memory, is very is criticized for being very simplistic. So this is a much more detailed explanation. It was developed by Baddeley and Hitch, same Baddeley that did the memory research on coding earlier on. So developed by Baddeley and Hitch in 1974. It focuses on the mental space that is active when we are temporarily storing and manipulating information, and it's made up of 4 components. So learn these: the central executive, phonological loop, visual spatial sketchpad, and the episodic buffer. So the central executive is considered or described to be like a boss, and sort of controls whether you're using the visual spatial sketchpad or the episodic buffer, and they both link back into long-term memory. And then the other part is the phonological loop, which is made up of the articulatory control system and the phonological store. So this is quite a good image to try and help you recall the 4 parts. So limited storage in the central executive, and so therefore that's why it sort of just is like this control system between the 2. Visual spatial sketchpad, think of that word as this eye image. It's used for when you're planning. So if you're walking somewhere or you give somebody directions, you would think through the route that you're traveling, and that's your visual spatial sketchpad. Remember, I talked through, think of how many windows are in your house and you had to count how many windows. So that was using your visual spatial sketchpad, and the counting was the articulatory control system from within the phonological loop. Don't worry if you're going for, you're not going for the top marks, don't worry too much about these 2, although they are mentioned on the specification, but just try and aim for these 4 at this point. So phonological, phono comes from the word is like sound, so phonological, listening, so it's the loop, it's listening, it's language. Okay, so when you're counting the windows in your house, you're using that to count, and this to plan around your house. And then temporarily, when you're holding that information as you're going around your house, recalling how many windows or keeping them in one place in your mind, you'll be holding that in your episodic buffer. Okay, and then you would be accessing your long-term memory to remember the layout of your house and what it's like. So all of these things are working together, and that is your working memory model. Okay, so that's all, should all be in here. So the phonological loop and visual spatial sketchpad are sometimes referred to as slave systems, which are the components that work together. I'm not a big fan of that, but it does, that's how it can be referred to. It has limited processing capacity and does not store. And we've talked through this. So if we go with the phonological store, which allows maintenance rehearsal, the articulatory process, which allows maintenance rehearsal, and then repeating words in working memory until they're needed. And this is believed to be about 2 seconds worth, so very temporary of what can be said. Like if you're holding information for a brief amount of time, maybe when you're talking or about to talk, and often if it's longer than 2 seconds, then that information can go. And then you've got the visual spatial sketchpad. Obviously, I've talked through that. Again, it has limited capacity of around 3 to 4 objects, and it's broken into 2 parts: the visual cache and the inner scribe. So the inner scribe is like words and terminology. So the visual cache stores visual data and imagery, and then the inner scribe records the arrangement of objects in the visual field. Okay, so it might be worth just looking over those 2, but again, similar to the parts of the phonological loop, they're not essential. Certainly the AS will develop this next year as we go through to the A levels, so it's worth looking over it, but it's not essential. And then in 2000, Badley added in the episodic buffer. So this was added in based on quite a lot of criticism, because it was kind of, he originally said the central executive had no storage, and then the other two had very limited storage, so he got criticised, and he was like, oh, okay, I've done some more research, and added in, kind of thought, well, actually there is a temporary storage going on here before it goes to long-term memory, and that's known as, he referred to as the episodic buffer. It brings information from the visual, spatial and verbal information processed by other stores and maintains a sense of time sequencing. It can be seen as the storage component of the central executive and has a limited capacity of around 4 chunks. It also links to long-term memory and wider cognitive processes such as perception, so how we see the world. So one piece of, or a strong piece of research evidence for the working memory model is by Shallis and Warrington on a case study called, referred to as KF. He had a motorbike accident and he had poor short-term memory ability for auditory information, but he could process visual information normally. So his immediate recall of letters and digits was better when he read them than when they were read to him. So if he read them himself, he could hold that information and recall it, but if someone read it to him, he struggled to recall that information. So that was evidence to show the difference in visual and acoustic processing. It is unclear whether KF had other cognitive impairments which may have affected his performance on memory tasks. The trauma of the motorcycle accident may have affected his cognitive performance rather than the brain injury. So there could have been other things that caused his brain or his memory to be damaged. So that's obviously one of the sort of consistent issues with any of the case studies. You can refer to that as an issue, say HM, because he had epilepsy, so that could have caused changes in his brain that affected his memory. Clive Waring had a viral infection, so that could have caused damage to other areas of the brain that affect his memory. So you could, as long as you don't just say, oh, their case studies are limited, because they're just one person. If you say an example for why for each of those, whichever one you're referring to, that will then help you convert your marks. So another strength comes from dual task performance. So a dual task performance is when the participants carry out a visual task so they can either do a visual task and a visual task. So they were asked to describe the shape of a letter F and follow a light source at the same time. So they're 2 visual tasks, or they had to follow the light source and answer some questions. So as a visual and a verbal task, they could follow the light source at the same time as the verbal task much better than if it was a visual and a visual task, which again makes sense to us, doesn't it? That would be very difficult to do 2 visual tasks. So this is because on the verbal and visual, participants are using the phonological loop and the visual spatial sketchpad, whereas on the visual and visual task, they're just using the visual spatial sketchpad, so this is being overstretched. But this is a limitation due to the fact that dual task activities such as following the shape of a letter, following a spot of light, are unlike tasks that we do every day. So that's low in ecological validity. Again, if you use that term ecological validity, don't just say it's low in ecological validity, say it's low in ecological validity because following a task, a torch light and describing the shape of a letter F is not a task that people would do every day. So a limitation, again, is lack of clarity over the nature of the central executive. So Badley himself stated that the central executive is the most important but the least understood component of working memory. This is considered to be the most important part, but so this is going to undermine the validity of the explanation, and he said that himself. So that is definitely a limitation there. So we're going to go on to explanations for forgetting, proactive and retroactive interference, and retrieval due to the absence of cues. So interference is when 2 pieces of information disrupt each other, resulting in forgetting of one or both of the same or some distortion of memory. So interference is usually used as an explanation from long-term memory when information is struggling to be accessed. So it is used as an explanation for forgetting, but it's not necessarily for being forgotten. It's that it's there, but it can't be accessed. Okay, so there's two types of interference that you need to be aware of. Proactive interference, where previous learning interferes with the recall of new information. So I always remember that as proactive and previous. So the two P's, because again, it's similar to serial position curve, where you've got two quite similar things there. Proactive is previous learning interferes with the new learning, and then retroactive is where new memories interfere with the recall of older learning. So if you think PP and retroactive for older, okay, so proactive is interfering with the new, retroactive is interfering with older information, and try and think of examples of those. So there's some research evidence which comes from McGough and MacDonald in 1931. They gave 6 groups of participants the same list of words. They were then followed by a different list of words. The second list of words ranged from synonyms, so they had the same meaning, antonyms, the opposite meaning, unrelated words, consonants, syllables, and numbers. So they all had the same list of words, and then they all had a different variation afterwards. And the words that had the most similar, so the synonyms, produced the worst recall. So this showed that if they had, if the items were similar, then that affected recall. Okay, so this shows that similarity can have an impact on recall of previously learned information, and the best recall was numbers. Okay, so they all had the same list of words, but if they had numbers afterwards, they did better on the recall of the words than those that had synonyms afterwards. So nice easy example there. You do need to just make sure you know retroactive and proactive as an example for interference, and then you can use that research, and then you can go on and evaluate it. So a piece of evidence that it's supported in everyday situations. So Badley and Hitch asked rugby players to recall the names of the teams that they'd played against during a rugby season. I should say season, not session here. They all played the same amount of time, but the intervening games varied. So they'd all played over the same 3-month period, but the number of games had varied. So Badley and Hitch found that those players who had the most games intervening had the worst recall for the original game. So if they played one game and then had just a big time gap, and then they asked them about this first game, recall would be okay. But if they had the same time gap, but a number of different games here, recall for this game was worse, and that would be because of the interference. And this is a real world study, so it increases the validity of the study. But a limitation of this is that interference in real life is still relatively rare. I think we have it as teachers because obviously we teach quite a lot of the same or similar content, but possibly in the real world, people have that less. There's also a lack of control, as some of the rugby players may have been discussing the games with family and friends, and this may have improved their recall. So that is definitely a confounding variable there. Therefore, the retrieval failure due to lack of clues may have been a better explanation. So another limitation is that interference may be temporary and can be overcome by using cues, so there's hints or clues to remember something. So Tolving and Pottsger in 1971 gave participants a list of words organised into categories. Recall was 70% for the first list, but this got worse after each list, so the proactive interference. But once they were given the categories again, so that cue, recall improved back to 70%. So this shows that interference shows a temporary loss of accessibility, but not total disappearance. And another limitation is that much of the interference research is carried out in a lab. So researchers can control the variables, so the time learning material and then recalling it. Control over confounding variables also shows a link between interference and forgetting. But these studies use artificial materials and tasks, and we often learn information, forget it, and then recall it later, suggesting that interference is a So here we're looking at retrieval failure due to the absence of cues. Okay, so we referred to cues before, but this is looking at how cues can affect retrieval failure. So this is the first bit, is insufficient cues. So one of the explanations for forgetting could be due to insufficient cues. When we learn something, there are usually things around us which help us to recall it. If the cues are not available at time of recall, then forgetting occurs, and this would be retrieval failure. So this was developed by Tolving in 1983, said that a cue has to be present at encoding, so the learning, and retrieval when we recall. If the cues are different at either point, there will be some forgetting. There are also cues that are non-meaningful to the original information. So state-dependent forgetting, recall depends on external cues, so whether weather or place, and then state-dependent forgetting, recall depends on an internal cue, so feeling upset or sad. So this is being in the same or similar environment. This is about your own sort of mood or feelings. So Godden and Badley investigated context-dependent research and recall, and they worked with deep sea divers in the following conditions to see which had better recall. So they learnt some information, relatively simple information, underwater, recalled it underwater, or learnt it underwater, recalled it on land, or learnt it on land, recalled it on land, or learnt it on land and recalled it underwater. So you can see that there's same condition, same, different, and then same, different. And you can also look at the results here. So this is the easiest condition for learning and recall, because there's less things happening going on if you're learning and recall on land, and the recall was 38%. But this is interesting, where they learn and recall underwater, it was 32%, but in different conditions, on land to underwater or underwater to on land, it was 23 or 24%. So quite a noticeable difference there, showing that there's the cues within the environment when you're recalling can really help that recall. So for state-dependent recall, this came from Carter and Cassaday in 1998. So they did the same thing, but they changed people's state. So not too difficult, but there had been other research that showed if people had alcohol and were slightly drunk, and then recalled after alcohol, or learn in after alcohol and then recalled without alcohol, that had an impact as well. So they carried this out in a slightly more ethical way without giving their participants alcohol, and gave them an antihistamine drug, like a hay fever drug, but a particular one that made them ever so slightly drowsy, and it changed the participants from their normal functioning state. They then had to learn lists of words in the following conditions. So similar to the divers, learn on drug, recall on the drug, learn on drug, recall not on the drug, learn not on the drug, recall on the drug, learn not on a drug, recall not on the drug. And as per context, learning and recall in the same state had better recall than learning in a different state. So then the A03 is that retrieval cues can help overcome some forgetting in everyday situations. So we know that by retracing our steps, we can kind of remember information and things, which is very useful. But they may not have a strong effect on forgetting. It's helpful to know that we can do this. And there's a lot of research to support this theory. However, context effects are actually not very strong, so the contexts have to be very different before an effect can be seen. So therefore, retrieval failure due to lack of contextual cues may not explain everyday forgetting. And another limitation is that context affects the type of memory being tested. So Godden and Badley replicated their underwater experiment, but using recognition rather than free recall, and performance was the same in all conditions, suggesting this is a limited explanation for forgetting. So they did similar to the same as the diver study, but they had to recognize images rather than just recalling it, and actually they were able So why do leading questions affect eyewitness testimony? Excuse the spelling mistake there. So the response bias explanation suggests that the working of the questions has no real effect on participants' memories, but influences how they decide to answer. The word smashed makes it sound faster, so encourages a higher speed estimate. And it also encourages a substitution. So when they later heard about broken glass, they recalled smashed and linked the two parts together, unlike hit or bumped. So it actually changed the participants' memory when they were questioned a week later and they thought there had been some broken glass, but hit or bumped didn't think there had been broken glass. So there is research on post-event discussion, which is in the title. So after participants have seen an incident, there's been research to show that actually when they talk about it with their friends or peers, that can alter their memory. So Gabbett in 2003 studied participants in pairs. Each participant watched the same crime but filmed from different points of view. They were then allowed to discuss the crime that they had witnessed. When questioned afterwards, researchers found 71% of the participants recalled aspects of the events that they did not see in their video but had picked up in the discussion. So they'd checked out, they'd carefully set it up so they were all seeing different angles and they knew who'd seen what, and then afterwards they set them questions and they found that they had discussed these events and then were able to test the impact of post-event discussion. So this suggests that there's memory contamination due to the conversations, that the memory becomes altered. Alternatively, memory conformity can occur, so witnesses go along with each other to gain approval, and that actually memory itself is unchanged. So the factors affecting accuracy of eyewitness testimony. This is your evaluation for this section. So this has important practices in the criminal justice system, as we know that people who may have incorrect memories due to these factors around them. However, much of the research was carried out in a lab, so therefore it's got low ecological validity. Again, linked to those examples. So the substitution explanation of a limitation is a limitation because eyewitness testimony may be more accurate for some aspects of an event. Participants usually have better recall of items that are central to the event than those that are peripheral. So the main kind of factors that are going on, they usually have, it's less likely to be replaced by discussion. But post-event discussion can also merge explanations. So if they think somebody's a sort of skin colour or hair colour, they can sort of merge it to a mid-tone. Sorry, this has gone really small. So this is our factors affecting the accuracy of eyewitness testimony. So this is anxiety. So as we know, anxiety has strong emotional and physical effects, and it can have a negative effect on recall. So Johnson and Scott set up a classic study in a waiting room where participants would sit in a waiting room thinking they were going for like a meeting, and then they had an argument in one of the rooms. Condition 1, so the first condition, they then had somebody walking through with a knife with blood on it, looking angry. And then condition 2, the second condition, had a pen and grease on their hands. Everything else they kept the same. Afterwards, the participants were asked to identify from a series of images who had been walking through. 49% with the pen could identify the person that walked through, compared to 33% with the knife. And they are suggesting that they are then focusing on the knife here, and are so sort of stressed by it that they're not focusing on the person carrying it. But it has been found in real life example that anxiety has got a positive effect on recall. So I've really shortened some of these down here. Yule and Cutshall had witnesses at a gun shop, which was a very stressful sort of situation where there was a robbery and people were shot. But the witnesses were questioned afterwards, and they found that they had really good recall for the robber immediately afterwards, and also when they were tested 5 months later. So this contrasts with Johnson and Scott, because obviously the robber had a gun and this was real life, whereas this one, although they didn't know it was set up, it was more of a laboratory setup. So A03 for this, so it may be the unusualness of the situation in Johnson and Scott's example, so the knife and the pen, and not the anxiety that affects the recall. And there's also evidence to suggest that anxiety affects recall. So there's research carried out in the London dungeons, and they put people into different conditions of highly stressed or high anxiety, medium, low anxiety. And they found those that were in the high anxiety had worse recall for the event. So that supports Johnson and Scott's research. But then anxiety can improve recall. So this is going back to supporting Ewell and Cutshall, where there was a robbery in Sweden, and they found workers and witnesses had better recall the closer they were to the event, to the actual robbery. But this research, there's a confounding variable, as the witnesses were interviewed between 4 and 15 months after the event. So that can cause issues with actually the findings there. But it was a real life case, so showing that anxiety can improve. So we're just going to finish here. I'm not going to go through accuracy of eyewitness testimony. You can look that up in your textbooks. You just need to know. So cognitive interview is used to improve eyewitness recall of an event that they might have seen, and that's based on the research that we've looked at throughout memory, particularly avoiding leading questions, sort of cues, and so all of those things can help with the cognitive interview. And the 4 factors that they need, or they recommend, a report, get the witness to report everything, take them back to the scene of the crime, get them to reverse it in a different order, and tell it from somebody else's perspective. Okay, so this is the 4 points to look over, and then in your textbook you'll have a little overview as to kind of what's effective about the cognitive interview and any limitations there. So that's it. Thank you very much for watching my nearly an hour's video recall of memory. I will try and do a social influence one over the weekend. And any questions below, please put them below, or like or share with your friends and subscribe. Thank you.